we do have a quick question.
Sure.
So I'll go ahead and read it to you and then you can answer. So if you had brought them directly to the list of cards and your event handlers hadn't run yet, then we might be missing a new entry, right? Do you have patterns for showing pending state if you change the UI proactively? What happens if they hard refresh?
Oh, okay. You could do that. So what I've done in Brain Credits actually is when I don't have it on BuzzyGo, which is the demo app, but if I were to do that on Brain Credits and post this to my transcript, what I've done in the past, so notice that does tick down. So I post it to my transcripts when it comes up. Hopefully it comes up. Notice that caught up ahead of time. But this information that's being written down essentially is I'm keeping a little bit of information in a cookie sometimes. So that is one possibility to kind of keep that information in sort of a pending state if you wanted to do something like that. There may be entries that are pending, or maybe I wanted to just show information that is not fully in the read model yet. There are a couple different ways. One, you could do some polling. You could have a cookie that says maybe this thing isn't ready just yet. There are a couple different ways, but I believe with Brain Credits I've used cookies on a couple of occasions, and it seems to work out fairly well. I've also used the Azure Cache. So from my controller, before I issue the command, I'll stick a bit of information in the cache, essentially almost like a mocked-up version of what this transcript entry may look like, put it in the cache. And then redirect to this post confirmation page. When that post confirmation page's action method is run, it will check to see if there's like a pending cookie in the request. If there is, it'll check the cache first, see if there's any information in the cache it needs to pull out, clear out the cache, display it, and then expire the cookie. And then subsequent requests should go against the read model after that, and the read model should catch up at that point in time. So those are probably a couple of different ways you can handle those situations. So I hope I answered your question and didn't ramble too much. If you have another question, please add it in, and I'll get to it eventually. Okay, so we were looking at BuzzyGo, and I just kind of wanted to walk through from a code perspective what's really happening. So when I created that card, what I needed to do was the very first thing I'm doing is I'm doing a post back to my controller. So here's my create action method within my controller. Nothing really crazy going on here. We've all seen this before in MVC. And I kind of go through and parse through the request that's coming through and pull out the information that I need. And what I do then is I'm instantiating a new command, a new CQRS command called create card. And I drop create card basically into a queue, which is an Azure queue. So I have this facade called a queue command. It could be going anywhere that I really needed it to do. But what I do within my controller is I create a command, I drop it on a queue, I do some logging, which is another message that I'm sending out, and then I do my redirect. Now this is BuzzyGo. This is very simple, and there's really not a lot of caching of information or cookies that are being created like I was talking about with Brain Credits. But this is where you would do that type of work also if I needed to create a temporary cache item or something like that. But really from CQRS's perspective, this is what's happening. I create that command, I drop it, I do whatever else I need to do in order to clean up, and then I redirect. So my controllers are pretty thin in terms of what's happening. There's really not a lot of processing that needs to happen. It's really just constructing that message and dropping it in. So notice though that the command that I'm creating is called create card. So from a convention perspective, commands are in the imperative tone. You're telling the system to do something. So I'm telling it to create card, create a card. I can say mark a square, create a card, create a new user. That type of a tense. So what happens is that if you remember from the diagram, the command is created, it's picked up by the command service, and then it's handed off to the domain. So let's take a look at the command first. Create card. And the way I am using NCQRS as my CQRS framework. You don't have to, but I'm using that just because it makes a couple things kind of easy in terms of mapping commands to domains. I like how it kind of does that. So I'm telling it that this command, create card, that I'm creating, maps to an aggregate root constructor of class card in this assembly domain. So what NCQRS is doing behind the scenes is doing a little bit of reflection to say, all right, take the command and pass it off, instantiate a new card object using this command to instantiate it. But if you notice, the command itself is just a handful of properties. That's all it is. It's just a message. There's really nothing else to it. It has no logic, no business logic of its own. All that business logic is going to be in the domain. So let's go to the domain. So here's the constructor for card. The parameters of the constructor match up to the properties of the command. And so NCQRS takes care of matching those up for me, calling the constructor. And then within my constructor, I just do a little bit of work here. It's again, a simple demo, so there's not a lot going on. But if I need to do any kind of validation or anything like that, I would do it within here. And even here, as I'm creating a new event to say, hey, a card was created, I am doing a little bit more business logic work here in terms of create card squares. So within my business logic, I'm figuring out, okay, what squares go with what coordinate on the card. And I'm also having logic in there to say, well, should this card have a free square or not? If it does, mark the middle square of the third row as a free square. So that business logic is all being encapsulated within a domain, and it's all being kept there. So the domain is the guy that is going to apply events, essentially raise those events. So again, just like I did the controller, I'm instantiating a new message. This one is an event. So notice that the tense of the event is in the past. It's saying this card was created. So it's raising a new event. I could raise multiple events. I could call apply event a couple times if I needed to. But essentially now I'm creating a new class and saying, hey, this card was created. Whoever subscribes to this event now can handle it and do whatever they need to do. So let's take a look at the card created event. Again, it's just a message. It's just a series of properties. So there's really not a lot of logic going on. Actually, there's no logic. It's just getters and setters for the most part. So now, after the event has been raised, a event handler, the normalizer, could be subscribing to that event. So I have a denormalizer here for cards, and it subscribes to the card created event. And so when it finds one of these, or when it's notified that this particular event's been published, it's going to route that event down to my handle method for this particular event. And all this is doing now is taking the information that's in that event, and it's pushing it into my read model. Now I could have broken that up into a couple different events if I wanted to, because the normalizer is doing a couple things. But because of it being a demo, I wanted to keep it kind of simple and kind of keep things sort of in one method. But really, it's kind of how you want to handle it. It's sort of up to you. So my handle event for my card created event basically goes through and says, all right, what's my connection string? Create a new card entity, populating it with the values from my event. Notice I'm not querying anything to get those values. It's assuming that that event has all the information that it needs. There's some default information that's being set by the denormalizer. And then I instantiate a new data context. This is linked to SQL. Again, I could have abstracted this out and used dependency injection, but because it's a demo, I wanted to make it kind of quick and simple so you guys can see pretty much what's going on. So I can update all the different buzzwords that have been clicked. I want to keep track of how many have been checked over time and how many have been added to cards, so I'm kind of keeping track of that. So the number of times that a buzzword's been used, I'm incrementing those counts. And then I'm taking that card that was created up above and inserting it into the cards table, and along with all the different squares that go along with that card, and then I submit my changes. So the denormalizer itself does really just the database work, just the inserts, the updates, the deletes, and the reads in order to get some information. That's all that the normalizer does. It's not applying logic. It's not applying rules. It's just saying, I have an event. I need to push that event down to my read model. This is how I go about doing that. So once we've gone through the normalizer, the read model's been updated, and everybody's happy. So that command now to create a card has moved all the way through, all the way down to the read model, and it's just waiting for that controller to say, hey, repository, give me back all the cards that have been created so I can show the user their cards. So in a nutshell, that's really what's going on with CQRS. So hopefully that makes sense to everyone. There's not a lot of questions out there.